We'll be dealing complex analysis today. So what do you mean by complex numbers? Any number that can be expressed in form of a plus ib, where a is the real part and b is the imaginary part. Imaginary part is nothing but root of -1 is equal to I. So this will be your imaginary part, and a is the real part, consists of real numbers, which is nothing but natural number, integer, rational and irrational. Now considering an example where we consider a integer, example 10. Can you express this in form of complex number, that is a plus ib? Here we have only 10, but we are asked to express it in complex form. Here we can express 10 as a real number by writing 10 plus I into 0, because we don't have any imaginary part here, so a real number can be expressed in form of a complex number. Next we are going to see the representation of complex number. The complex function, the first one will be polar form r theta. Considering this will be the real axis, this will be the imaginary axis. From the origin to the point z, this is known as mod z. Mod z is nothing but root of x square plus y square. This angle between z and real axis is theta. Theta is nothing but it is the amplitude or the argument of z is theta, which is equal to tan inverse of y by x. So first form will be polar form. It is written as z is equals to r cis theta. R cis theta is nothing but r into cos theta plus I sin theta. So this is in the polar form, r and theta. So for example, we can consider cis 0, which is nothing but cos 0 plus I sin 0. Cos 0 is nothing but 1 plus I into sin 0 is nothing but 0. So the answer will be 1. Considering another example, cis pi. So cos pi plus I sin pi. What must be the answer? So that will be -1 plus I into 0. The answer will be -1. And not only for pi, we can do it for pi by 2, pi by 4, etc. according to your need. So the next type comes the integer power of z, where n is the power of the integer that also belongs to the integer. Considering z power n is equal to r power n cis power n, which is written as r power n cos n theta plus I sin theta. Where next comes the exponential form e power I theta. E power I theta is nothing but cis theta. Cis is cos theta plus I sin theta. Now we have covered the three representation of complex function. First is the polar form, which is z is equals to r cis theta, integer power of z r power n into cos n theta plus I sin n theta, and exponential form ei theta is equals to cis theta. Now to solve the problems of complex analysis, you have to remember two formulas which is necessary, where this one is represented in the hyperbolic function in the form of hyperbolic. So cos ix is written as cos hx. This will be the hyperbolic function of this. Sin ix can be written as I sin hx. So these are based on the derivation, which will not be covered in this. So it's enough if you remember this particular formula. Now we can go solve the problems. So here comes the first problem. First problem is log z. Considering z first, we can't solve in the form of log z, so we have to simplify z. Z can be written as x plus iy in Cartesian form, and x plus iy can be written as r cis theta in polar form. This cis theta is nothing but e power I theta according to the exponential form. So z log z can be written as log r into e power I theta. Separating both, we can write log r plus log e power I theta. Log r remains the same plus log and e, so it becomes I theta. So log r is nothing but root of x square plus y square. As I told you before, the modulus of z, here it's r, so the modulus is nothing but x square plus y square, and theta, the argument or the amplitude, what I told before, theta is nothing but tan inverse y by x. So this equation is written as log of root of x square plus y square plus I tan inverse y by x. So by this, it is in the form a plus ib. So the real part is nothing but log root of x square plus y square, or 1 by 2 log x square plus y square, and the imaginary part is tan inverse y by x. So this is the first problem. The next problem we'll be dealing is sine x plus iy. How will you solve this? So we are going to use a formula x plus y, or a sine a plus b formula, which is nothing but sine x cos iy plus cos x sine iy. So this is the formula. As I told you before, using the hyperbolic function iy and sine iy. Here sine x is written as the same thing, and cos iy is nothing but cos hy plus cos x is written as it is, and sine iy is written as I sine hy. So writing it, simplifying it, we get sine x cos hy plus I cos x sine hy. So it is in the form a plus ib, where this is the real part and this will be your imaginary part. So we solve the second problem. Same like that, we can solve the third problem. Third problem is cos x plus iy is equals to, you're using cos a plus b formula. Cos a plus b formula is cos x cos iy minus sin x sin iy. So as I solved the previous sum, this x cos x remains the same. Cos iy is nothing but cos hy minus sin x remains the same. Sin iy is written as I sin hx. So simplifying it further, we get cos x cos hy minus I sin x sin hy. So this is sin hy, so I sin x sin hy. So this will be your real part, this will be your imaginary part. As a bonus problem, I'll be solving another problem where you get a hyperbolic question. Here cos h x plus iy. Here cos h, you can't solve it as the previous sum, you have to simplify this. So considering this as one element, right, cos hx, cos hx. Cos hx is written as cos ix, which is equal to cos I into x plus iy. Cos hx is cos ix. As I said here, cos iy is cos hy. Same like that, cos hx is equals to cos ix. So considering this, I told you consider this as the whole term. So x plus iy, replacing it in the place of x, you get cos ix plus iy. So cos I into x plus iy, multiply I inside, so that will be cos ix plus I square into y. I square into y is nothing but, see, I square is nothing but minus 1. So we write cos ix minus y. Simplify this using the formula. So that will be cos x cos y plus sin x sin y. Since it is imaginary here, cos ix, you are going to write cos hx. This will remain the same, plus sin ix. Sin ix is nothing but I sin hx. This will remain the same, sin y. So we got the answer in the form of a plus ib, where this will be your real part, this will be your imaginary part. Yeah, thank you.